In some earlier videos, we looked at some ways we could use factoring to solve some problems, such as adding and subtracting rational expressions. In this video, we're going to use factoring in order to solve equations. And in particular, we're dealing with equations that involve polynomials. But this method will work for anything that you can factor. Now, one of the things we're going to be using is a property of zero, sometimes called the zero product property. We know that if we multiply any number by zero, we get zero. So if I multiply several numbers together and I tell you that the answer is zero, then you know that at least one of those numbers has to be zero. That's the only way you can get zero. Or it's possible that more than one is zero. So if I say or write x times y is equal to 0, the only way that can happen is if x is equal to 0 or y is equal to 0 or if both are 0. Either way I'll get 0. So that makes it convenient to solve an equation if we can factor. So in the first example, we want to solve the equation x squared minus x is equal to 6. Well, in order to apply this property to 0, I have to have a product equal to 0. So I have to rewrite this equation so that one side is 0. So let me write it as x squared minus x minus 6 equals to 0. Okay, so the right side is 0. So now the object then is to express the left side as a product. Okay, so this is where we use the techniques for factoring, in this case a trinomial. Okay, so we know the factors of x squared are x and x. Okay, let me rewrite this again. E equals to 0. So again, in order to apply this property of 0, I want to write a product equal to 0. So that's why I make the right side 0 by bringing the 6 over, and then I try to factor the left side. So it's a trinomial. The factors of x squared are x and x. So I put x and x on each set of parentheses. The factors of minus 6 or 6, we can do it positive or look at it as a negative. Either way, we have to put the signs here in the parentheses. So factors of 6 are 6 and 1, 3 and 2, but we need to come up with a minus 1 for that middle term. So the combination that will work is if I make this a minus 3 and over here a plus 2. So I have then a product. X minus 3 represents a number, x plus 2 represents a number, and the product of those two numbers is 0. The only way that can happen is if one of those or both of those are 0. So basically what we do is we set each factor equal to 0. So we take x minus 3, set it equal to 0, and x plus 2, set it equal to 0. And then we just solve. Okay, so these are not two linear equations. That is first degree equations. So on the first one I add 3 to both sides to isolate the x. So minus 3 and 3 cancel. 0 and 3 is 3, so I get x is equal to 3. Over here, to isolate the x, I add -2 to both sides. So I cancel the 2 on the left side, and then 0 and -2. Here's -2. So this is going to be x is equal to -2. So I can write my solution as x equal 3, or x equal -3, or I can put this in terms of a solution set, 3 and -2. So that's my solution. And you can easily check this. You put a 3 there, 3 squared is 9, minus 3 is 6. So I have -2 squared is 4, I should say, and the minus of -2 is 2, so I have 4 plus 2 gives me 6. So that checks out. Okay, let's clear this. Now the next one's already pretty much set up for us. So you can have the product of 3 factors or 10 factors. It doesn't matter if it's factored out, and as long as one side is 0, that's the key. The product has to equal to 0. Then you just take each factor and say it equals 0. So the product of these 3 is 0. That means either one of them or all of them are 0. X minus 4 can be 0. 2x plus 1 can be 0. 5x minus 3 could be 0. So we just set them all equal to 0. So I get x minus 4 equal to 0. 2x plus 1 equal to 0. And 5x minus 3 equal to 0. Okay, then you just basically solve each equation, isolate the x. So the first one, I add 4 to both sides, and I get x equal to 4. That's one solution. For the second equation, to isolate the x, first I isolate the 2x by adding a -1 to both sides. That'll give me 2x is equal to -1. Then I divide both sides by 2, and I get x is equal to 2 -1/2. Okay, so that's my second solution. In the third factor, I isolate the term with the x, that's the 5x, so I add 3 to both sides. That leaves me with 5x on the left side, and 0 and 3 is 3. Divide through by 5 to isolate the x. So x is equal to 3/5. So I get x equal to 4, x equal to -1/2, x equal to 3/5. And of course, if you want the answer in a solution set, you put your set of braces and then put those numbers in the solution set. So 4, -1/2, and 3/5 is the solution to that equation. Clear? And then the third example. This one I have one side is 0 already, so I don't have to do anything there. But then the left side consists of a polynomial, but it has 4 terms. So again, I have to try to factor this out. So different methods for trinomials, methods for binomials. In this case, when you have more than 3 terms, a lot of times what you want to do is try to see if you can group. So notice the first 2 terms have an x squared in common. I can take out an x squared. So that would leave me with x. And then I'm taking out an x squared, so its coefficient is at -1, so that's going to stay -1. And remember, the object, when you take out a when you apply the grouping method, is you're factoring two groups basically most of the time. Sometimes it could be more, and you want to find something in common with those two groups, so you can apply the Gcf method and continue the factoring. So notice the last two terms, the minus x and the plus 1. In order to come up with a common term here, I need to take out a negative 1. If I take out a negative 1 from the last two terms, that will leave me with x minus 1. Now you can see that both groups have a common factor of x minus 1. That's your GCF. So I take out the x minus 1. So x minus 1. Factor that out. So in the first group, put a parenthesis here. That leaves me with x squared. In the second group, I'm taking out the x minus 1. So that leaves me with a minus 1. Okay, the right side is still 0. And then I want to make sure that I factor as much as possible. So I'm going to leave the x minus 1 the way it is for now. And x squared minus 1, see that's a binomial, that's a difference of squares, so that factors into one of the methods we covered earlier, x minus 1 and x plus 1. Equal to 0. Okay, so I have the three factors. Notice two factors are the same, x minus 1, x minus 1. So if I set each factor equal to 0, you get the idea of what we're doing now. If I set this one equal to 0, that factor is going to equal to 0 when x is 1. So 1 is a solution. Obviously the second one is going to be 0 also when x is equal to 1. It's the same factor. And then the third factor is going to be 0 when x is negative 1. So the solution set is x equal to 1, 1, negative 1. So we have a repeated root. So we can write the answer as x equal to 1 and then comma x equal to 1, comma x equal to negative 1. Or we can write it this way. Again, just x equal to 1 or negative 1. Or since those two are repeated, sometimes we don't give it a repeated solution and we just say it's 1 and negative 1. So depending on what they ask you for, the actual solution consists of the numbers 1 and negative 1. 1 is a repeated solution. If you're asked, it does have a repeated solution. Okay, so hopefully this will help you if you're solving equations by factoring. Keep in mind that this method is only going to work if the equation is factorable, or put it another way, if you're able to factor it. Okay, there's other methods that you can use. Obviously there's graphing calculators that can also solve equations. So this is just one method. If the equation is factorable and you can easily find the factors, and that's the easiest way to do it. So we'll pick it up here in the next video. So please subscribe to the channel if this is helping you.